Okay, in this video we're going to explore what's called a limiting reactant. Okay, and this is another feature that basically takes stoichiometry and puts it into kind of real life terms. Now, before I start this, let me explain and remind you something we just discussed in the other video. In a perfect reaction, 2 moles of sodium would react with 1 mole of chlorine gas to make 2 moles of sodium chloride. If I had those exact amounts in terms of moles, there would be nothing left over. Everything would perfectly react, and those are the exact ratios we would need for everything to get used up in our reaction and everything new that could be produced to happen. Now, oftentimes in real life, that's not the case. Sometimes you have too much sodium and not enough chlorine, and so you react them and there's some extra sodium left over. Or sometimes there's too much chlorine and not enough sodium, and you'll have extra chlorine left over. And so what we need to do when we're given some amounts or some measurements to start with is we need to figure out which one of these things is going to get used up first. Because as soon as one of the reactants is used up, the reaction stops. It can't keep going on if there isn't the right amount of reactants to make it necessary to happen. So in this case, I just picked some numbers. Okay, so numbers that would be relatively easy to follow and interpret. If we happen to have 92 grams of sodium, and we happen to have 106 grams of chlorine, what we want to know is which one of these is the limiting reactant. Essentially, which one gets used up first and causes the reaction to stop. And then the other one we would call the excess, the one that has some leftovers. Now, the only way to accurately measure, compare these two is to put them in terms of moles. That's definitely something we always have to do in any stoichiometry situation. So I'm going to take 92 grams of sodium, and I'm going to do a little one-step conversion here to change it to moles. Okay. And so I look on the periodic table and I find that 1 mole of sodium is 23 grams. So when I take 92 divided by 23, I get about 4 moles of sodium. Okay. So this is really, what I'm going to do is I'm just going to cross that out. I'm going to ignore the 92 grams. It's kind of a deceptive number. I'm going to take 4 moles. Let's do the same thing with our chlorine. 106 grams of chlorine. Let's change that to moles. And let's see, 1 mole of chlorine gas is about 71 grams. So I have about, and this doesn't have to be exact, you can get pretty close, I have about 1.5 moles of chlorine. So I'm going to cross this out and put 1.5 moles. Okay. Now it becomes a situation that I'm just going to have to look at and analyze. I might need to do it mathematically, or I might just be able to do this in my head. So what this means, I got 4 moles of sodium present, okay, in the same container or whatever, wherever this reaction is happening. I got 1.5 moles of chlorine. Now, according to my reaction, my balanced equation, I need 2 moles of sodium for every 1 mole of chlorine. So it's saying I need twice as much sodium. Now, when I look down here at my numbers, I have 1.5 moles of chlorine. What would twice as much of that be? Well, what's twice as much as 1.5? Well, that would be 3. So I need 3 moles of sodium to completely react with 1.5 moles of chlorine. So this is what's needed right here. Okay. Do I have that? Well, yes. In fact, I have extra. Okay, I need 3 moles, but I actually have 4 moles to work with. So what that means is sodium is extra. We call that excess. Okay. Chlorine, on the other hand, there isn't extra of that. So chlorine would be my limiting reactant. And why is limiting reactant important? Well, if we had to do some further stoichiometry, like let's say we were all of a sudden asked to figure out how much sodium chloride was produced, well, one of these amounts matters and one of them doesn't. And the one that's important is this. If I were asked to do some further stoichiometry, this number right here is what I'm going to use as my starting amount, like we did in the previous video. I'm basically going to ignore this because it's deceptive. all of those moles of sodium aren't going to react. So if I use that number, it's going to mislead me and make me think that I'm actually having more of a reaction than is really taking place. So limiting reactant, you have to find it by comparing moles, and then you have to use it for all the rest of your stoichiometry. The excess reactant, we can figure out how much is left over, but other than that, it doesn't. The amount we start with in excess doesn't really matter.